The first step, I think, is you need to connect to T4. So by default, it's the CPU, but you can change the runtime type to T4 GPU. I think this is already sufficient to run today's demo. Okay, it's already connected. So today, I hope to get you set up, right? To make your first step to build a simple AI agent and can start chat with that. So that's the goal of today. And I choose Ollama because Ollama is kind of like a local server, and it provides serving all the kind of LLMs, I would say, like open source LLM or small language models locally, so that you can make API call directly to this LLMs locally. And if you are interested about like what models are offered by Ollama, so you can click on this link, and then you will see a series of most popular and also powerful open source LLMs or SLMs, small language models, like Qwen 5 series, Qwen from Alibaba, 5 series from Microsoft, Llama from Meta, DeepSeek, right? The powerful like reasoning, the R1 model, and also Coder from DeepSeek, and also Mistral and the Minimax. And then the first will be installing all the dependencies. First is the Ollama dependencies. Because I want to get the Ollama server running locally, right? So you can just run this dependencies and run this command line, and it's able to just install the Ollama on Colab. And Colab actually just a Linux system. So you can just run this command and then get the Ollama server running. Yeah, so if you run this, you should see this like populated at your web page. And then you may see some warnings, but it should be successful on the Colab if you see instance. And then once this Ollama has been installed on this Linux environment, and then the next is to get it up running. So if you run the Ollama locally at your laptop, you can just run Ollama serve in your command line, and then the Ollama server is up running. But due to we are in Colab, right? If you run this block, it will keep going, it never stops. So because we want to demo it on Colab, and then you can just have a sub process to run this Ollama server so that you can have multiple threads, right? So one thread just to get the Ollama server running, and then you can move to the next step. So this is just to get the server running. And then for today's demo, I choose to use Qwen 3.4b. About like why I choose this is based on my current experience. Is like Qwen 3.4 BDM model is really a powerful open source model, and it also has a very long context. So if you have any use case, try to benchmark with this to see if it's already be sufficient for your work before you move to like a more expensive, say, Cloud for or OpenAI API. So you can see that it supports Llama 3 as well. So you can pull Llama 3, but there's a lot of other models for you to pull. And Qwen 3, like you have like 4B up to 200 plus billion. If your local GPU is able to host this. But like for today's demo, I just choose the 4B. And actually, let me try to run this. So if you, when I'm running it, feel free to run it on your end as well to catch up so that you can talk with it later on. I think it takes a while to install it on this instance. So it's just downloading this installation package to this instance. So right now, after if everyone is able to run till step 3, then I think right now you should have the Qwen 3 already downloaded, ready. And then I choose to use Strands agent. Strands agent is open source SDK by AWS. And why I use it, because at a later stage in the series, I also want to leverage AWS like Agent Core or other available AWS services to directly deploy your agent in production. Due to that, I want to show that, and also due to the Strands can easily connect it to AWS resources. So I choose to use Strands agent, but also feel free to use other frameworks. I think other frameworks should also work, like the BAN series. But my focus will mainly you choose to use the Strands agent in order to deploy it more conveniently to AWS in the future sessions. So the Strands agent, right now we focus on one single agent, right? So there are mainly like 3 components, like the model. So it offers very flexible model support. So you can use Amazon Bedrock. Amazon Bedrock also is like a service that hosts many different types of models, just like Ollama. But Ollama is more like a local hosting of models, right? Bedrock is like already optimizing the inference and all of that, and the API is already ready to use and able to scale. And also you can choose to directly use the cloud API or OpenAI API with Strands as well. And then to be a powerful agent, you also need the tools, right? So there's already available tools provided by Strands, and also you can connect it to MCP for other types of tools, or you can also define your custom tool. Today, we mainly focus on the setup and get a one single agent running. And then the prompt, right? So the prompt is more like the system prompt to define the role of the agent, etc. So this is more like an agent loop to get you understanding what is under hood, right? So you define the prompt to the agent, and the agent will invoke the model of your choice. So right now it's the Ollama Qwen 3 model hosted on Ollama server. And then it's going to give the response to the agent, and the agent can also decide whether it's going to execute some tool, and then compile the results and get the results back. Yeah, and in order to do this, you need to also run all the dependencies for Strands agent, just using the pip install, like the Strands agent for the package itself. Strands agent tools is kind of a package to provide the already built-in tools for Strands agent. And this is like a package just for connection to Ollama server. And to create a Strands agent, right? So you can first get the Ollama model to define the Ollama model. So you can define the host. I think this is just a default local host. And if you are wondering why the port number is 11434, actually this is just symbolically like very looks like llama, right? Like LL is 11 is LL, and 4 is like A, and 3 is M. So so people, and that's why the Ollama they just kind of use this port as a default there. And then you can specify your model, which is already downloaded when you do the pull in the command. And then you can define your agent, right? So agent, you can pass this model, and then you define your system prompt there. So basically I just here like just define this is a helpful assistant, and then you just answer user queries, and also honestly say, I don't know if you are uncertain about it. So after you run this, and when you first invoke the agent, for example, pass, hello, who are you, right? And then you see the GPU memory increase. So basically the Qwen 3 4 billion model is loaded into GPU when you first invoke the agent. So this is how you invoke it. You just pass the message to the agent. Just to show you what the returning object is, actually an agent results object, and includes all the messages. And then the response is actually over here, right? So hello, I'm Strands, your friendly AI assistant here, right? So if you're able to get this, it means that your Ollama server is running and the agent is successfully connected to that Qwen 3 model. Okay, and then let's do some interactive chat over here, right? So if you run this, so this is just a simple while loop. And then you're trying to get some inputs over here. For example, I want to ask, okay, list the top use cases for AI agents. So right now, there's no internet connection for the agent yet. So this is fully based on how the Qwen3 is pre-trained, right? So this is fully based on the knowledge already while in the model. And then it's going to kind of execute this, and then it takes a while to return me. I think just trying to be friendly. I'm glad you asked. And then here's some impactful adopted use cases like customer support, personalized recommendation, business, healthcare, predictive analytics. And then it also asked me, do you like to deep dive into anything? And I said, yeah, deep dive into one, customer support. So I want to show this because it's all the output from the agent is automatically stored and served as the input to the next round, right? So because this is like a loop, and every time you put something to the agent, the inputs and outputs is going to be automatically stored as the memory for the agent for the next round of conversation. And this is implemented by default by Strands agent. So I just say like deep dive into one, it should learn that, oh, I'm asking for the customer service. Let me see whether it is correct. Yeah, so absolutely. Let's dive deep into the customer support, right? And then like why this is the number one use case and the stages of the solutions, workflows, critical challenges, etc. So I think it's a reasonable response, and also future evolution, etc. By default, it's going to kind of store all the prior inputs, outputs in the context for the next conversation. And you see a problem with that, right? The more turnaround you have, the input tokens is going to significantly increase, which will, and maybe even at some point, it will even like out of context window. That it cannot no longer have the conversation, right? So you need some mechanisms to manage the messages. And also for some applications, like you just need a one-time call for a specific function. You don't need this conversational style. So how can you manage this conversation? Is this agent has a conversation manager? Right now, I'm using a summarizing conversation manager, which is like, I'm going to summarize 30% of the messages. So it's like a summarization is automatically running. And also, I also want to preserve the most 10 recent messages in the context so that the recency is also preserved. But over time, I expect the input tokens will be stable at some level so that it will not forever growing in the input, right? So, and then I can pass the conversation manager to the agent so that this agent will automatically manage the messages for you. And to your questions about the single turn, there is a now NULL conversation manager. So you can search the Strands agent conversation manager. And if your conversation manager is like a now conversation manager, it means that it will treat each input as just a standalone request rather than this multi-turn conversation. So this is the messages management. And then what is the latest news there? So in order to answer that question, you need to have access to a search API or search tool, right? Right now I use the Tavili because it's already a built-in tools from Strands tools. So you can just import the Tavili search from this. But in order to use this, you need to go to the tavili.com. So you need to go to this website, and I'm already logging. Yeah, so right now you see I'm a researcher plan and I have 1,000 credits. I think corresponds to 1,000 free search course. So I'm a kind of just registered as a researcher and I got free 1,000 search course here. And then you see I have a key, right? So you can click this I and then copy the key. Copy the key, and then you can move it to the secrets management on Colab, right? So you can create a Tavili API key and copy the key over here, and then enable the access to this notebook. And then you can load this key in your kind of the environment variable on this Linux machine, so that your environment kind of know the search API key. And then you can just straightforwardly using this search. So I'm going to run this step and also run this. So you see the tools is like a list, right? So you can actually pass a bunch of tools to this. And then right now your agent is powered by a search tool. And then you can ask, okay, what are the key findings of the latest AI safety research? And the agent should reason about this and figure out, okay, what are the search query I should pass to the search API, and it's going to call the search API. So you may see something like this over here. Yeah, so you see the Tavili search results. So it means the agent has, and then the query is latest AI safety research key findings. And they basically, the agent calls the search API, translate your query into this search query, and then execute that API, and then find, okay, what is the latest news about the AI safety? And then in the end, actually the results is like a very long. In the end, yeah, so in the end, it should compile all the results, and then the agent is going to respond to a summary to you, right? Like the AI models, what's this deceptive behaviors, AI development, outpace safety protocols, critical needs for the guardrails, et cetera, et cetera. So basically it's going kind of agent is able to look at the results from the search tool and is able to summarize the key findings for you as the final response. Yeah, so I want to also show you like how you are able to connect with search, because I think the search tool should be there by default, or else the agent is kind of outdated, can easily get outdated. You cannot get any latest news or latest trends in your response. So you can define your search tool, just reuse what Strands has, and then you can find the latest news about anything you care about. Okay, I think this is the basic agent I want to show you all, and I hope you are having fun to play with it. At least I think it's able to at least like a 1,000 course for this search. And also, if you have identified any other search engines or APIs like a good fit for the agent, let me know as well. I'm also curious to see like what will be a good search engine tool for the agent. And I think last, I do want to show you the Bedrock backend. Because Strands is developed by AWS, so by default, actually, it's like connected with the Bedrock backend. And in order to connect with the Bedrock backend, you need to have your AWS credentials. These are the prerequisites. Like you need to have the AWS access key IDs and also the secret key in order to call the Bedrock. And how to do that? If you are not an AWS user yet, first you need to create your AWS account. Just assume that you have create your root user account, and then you need to go to the IAM. So this is more like a user management control, and then go to users. So you see me created multiple users here. So you can create a user, and then this is like a Bedrock, let's say Bedrock test user here, and then next. Next, the user, the main permission for the user, I think I just need the Bedrock, right? So I can just attach policies directly and search the Bedrock. I can give the full access to the Bedrock here. And then you can click next. Okay, so I create a user, Bedrock test, etc., and then I can create this user. So you see I create this user, and right now I want to get the key ID and also the secret keys. So go to this user, and then you can create access key, right? So if you create a user, and then you can create access key here, and then right now I think I'm doing an application running outside AWS. I just want to have Bedrock call. Description is Bedrock tag. And then I can create access key. So you see I got the access key name and also the secret here. and then you can copy it, right? Copy paste from the users, like retrieve the access key here, and then copy paste it over here. You can also specify which region you want this Bedrock API to run on. So I think some default popular ones, East 1, East 2, West. I think you can just choose the East 1 there. And then after you configure the keys, then you can run the next steps. Like I can grab all this AWS key and secrets from this secrets vault, and then the only difference is like the model, right? So you can right now define a Bedrock model instead of an Ollama model. And then you pass the model to the agent like that. And right now I just ask like, who are you? Because I want to make sure that it's not a Strands, it's a cloud right now, because I specify the model to be a Cloud 4 model on Bedrock. So if you run this, it should give you a response like I'm cloud right now instead of I'm Strands agent, meaning that I'm already connected to Cloud 4 over here.
So basically, there might be some potential charge for this one, right?
So every time you make a call to the Bedrock model, you should be able to see it in your AWS account about how many calls, and then the cost is charged based on your input tokens and output tokens. So there is like a unit cost per 1,000 input tokens, and also a cost per 1,000 output tokens. Bedrock, yeah, you can run on CPU. Any laptop can just run this. So if you say if you don't have a powerful GPU, but you want to explore like building agent, and then you can also choose any API at your choice, right? But that comes with a cost, like either using Bedrock. Bedrock also provides you a family of models to choose from, including cloud, and then all the other options, other models. So you can see the full list of models already hosted on Bedrock. You can also configure Strands with OpenAI API or Google API. And you can actually build an agent using these APIs at your local laptop, like, and which will require very minimal computing resources. But you need to pay the vendors because the model is hosted and run on their end. Yeah.
There's two other shortcuts too that you can do if you want to run it locally. One, you can pick a program model where you can put pretty much everything on the CPU. It'll take forever for the computation to happen. Yeah. And then you can also look at the GGUF versions of various models. So there's a way that they actually cut off some of the computation. So instead of taking a computation out to like 16 digits, it'll only take it out to like 8 or like 4. So it won't be quite as precise as the original model, but it will greatly reduce the size of the model. So you just have to kind of play around to make sure that as you're dumbing the model down a little bit to fit it on your computer, that it still does what you want to do. But you can do that all on Hugging Face.
There's about a 10 times performance penalty for running it on the CPU. But if you're on a Windows machine, you're limited by the GPU card that you have in the machine and how much video RAM it has, which can be 16 gigabytes. If you get a 5090, that would be 32 gigabytes. But on the Mac, if you're running this on a Mac, they have what's called unified memory, so that your entire memory space is accessible as video RAM to the GPU, or nearly your entire video space. So if you've got 64 gigabytes of RAM on your Mac, and it's an Apple Silicon machine, then that's unified memory. And so now all of a sudden, instead of having like 32 gigabytes of video RAM, if you spent $3,000 on a RTX 5090 GPU from NVIDIA, now you have 64 gigabytes of video RAM on your Mac, which probably costs less than the NVIDIA GPU. So, so that's another option as well. It's because of the architectural differences that you have a lot more flexibility on the Mac side. And you could run the GGUF models if you want, and quantized and so forth. But normally you'll probably double your performance if you convert them into the MLX format, which is what Apple's Core ML machine learning system is designed to use. So those are the MLX files are optimized for the Mac, although you can run the GGUF models as well.